Hi, this is Mr. Nazarian. Our learning objective today, I can identify relationships between two number patterns. 5th grade standard, operations algebra, B3. So, first of all, we need to know what are numerical patterns. Well, numerical patterns are a sequence of numbers that follows a specific rule using addition, subtraction, multiplication, and or division. It could be a combination of some of those different operations. So, let's say that Cadence and Kinzie both decided to start a shell collection on their trip to the beach. Each day that Cadence went beachcombing, she found 3 shells that she kept. Each day that Kinzie went out, she kept 5 shells to add to her collection. Show how many shells each of the girls had on the end of each of the days they went beachcombing. They both were at the beach for 4 days. Find the relationship between the patterns of their shell collecting experiences. Okay, so we are going to create 2 different numerical patterns here, one for Cadence and one for Kinzie. So for Cadence, remember it said that she started with none, right? She started with no shells because this is a new collection, but each day she added 3 shells to her collection. So the rule is to add 3 shells each day. She started with 0, but at the end of each day, she had 3 more. So at the end, she started with 0. At the end of day 1, she had 3. At the end of the day 2, she had 6 because she added 3. At the end of day 3, she had 9 because she added 3, and so forth. Kinzie had a different rule. She had a different numerical pattern. Her rule was each day she added 5. So again, she also started with no shells. This is a new collection. But at the end of day 1, she had 5 shells because she added 5. And the second day, she had 10 shells because she added 5 to what she previously had, and so forth. 15 and then 20. So that's the first thing that we need to figure out. But again, remember, we're trying to find out what the relationship is between those patterns. So we're going to look at what's called corresponding terms. So here's what Cadence collected. Here's her numerical pattern, and here's Kinzie's numerical pattern. And corresponding terms I've color-coded here are the similar colors. So these green, they're both 0 because they both started off with 0 shells in their collection. In orange here, the 3 and the 5 represent the amount of shells that each of the girls had at the end of day 1. So Kinzie had 3, or Cadence had 3 and Kinzie had 5. In yellow here, these are corresponding terms, the 6 and the 10, because at the end of day 2, this is how many shells each of the girls had. Purples represents the number of shells that each of the girls had on day 3, and the red is day 4. Okay, so the question is, what is the relationship between each pair of corresponding terms? So in order to do that, I'm going to look at these corresponding terms. Between 0 and 0, really you could say anything, right? I add 0 to 0 and make it 0. I multiply 0 to 0 and I get 0. I subtract 0 from 0 and I get 0. So there's not a lot of clues that we can do with these zeros. But if we move on to the end of day 1 here, these corresponding terms of the 3 and the 5, then I can do something. So what operation could I use with 3 to make it a 5? I can't use multiplication because there's no factors of that I can multiply with 3 to get 5, right? I can't multiply 3 times any whole number and get 5. I can't subtract anything from 3 and get 5 because 5 is a bigger number than 3. And I can't divide 3 by any number and get 5. But I can add. What number would I add to 3 to get 5? I would add 2. So that is a relationship that we can find just within those the first corresponding terms, is that I added 2 to Cadence's term to get Kinzie's term. Then the second term here, the 6 and the 10, what relationship can you find between those numbers? What mathematical equation can you do use the 6 and the 10? So how can you change the 6 to a 10? What kind of operation and what numbers would you use? Okay. So if you said 6 plus 4, that works, right? Again, addition is the only operation that would work between a 6 and a 10. Okay, what do you think the relationship would be? The third term here between the 9 and the 15. 9 plus 6 is 15. Okay, and finally, what would be the relationship between the 12 and the 20? This fourth term on the end of the fourth day between Cadence's collection and Kinzie's collection. That's right. We added 8 to Cadence's collection, and then we got 20 here. So what pattern do you see? What is the relationship between each pair of the corresponding terms, and what is the overall relationship between these numerical patterns? So every time that we move along day to day, what is happening between the amount of shells that Cadence has and the amount of shells that Kinzie has? So what is the overall pattern that you can see? And so you can see here that the first term, it increased by 2. The second term, it increased by 4. The third term, it increased by 6. The fourth term, it increased by 8. Can you, if you were to make a guess as to how much it would increase, if there was a fifth day, it would increase by how much? Probably 10, right? And we can try that out by saying, well, okay, remember this is increasing by 3 each time, so 9, 12, that would be 15. Remember this is increasing by, Kinzie was adding 5 shells every time, so 15, 20, 25. Look at that. The relationship between 15 and 25 is plus 10. So the pattern that we're seeing in the relationship in the numerical patterns of these two are that each number in the second set increases each time by the next greater multiple of 2. So if you said something similar to that, that every time the corresponding term is increasing by the next greater multiple of 2, or it's increasing by 2 more than how much it increased by the last term, then you are correct. All right, we're going to work more on these kinds of math problems tomorrow in class. See you then.